Hi everyone, my name is Nariman and I'm the founder of Puter, the open source internet computer. In this talk, I'm hoping to share with you what Puter is and the how and the why of building it. Before I get started, I'd like to tell you a little more about myself. So I've been programming for 30 years now. Wrote the first line of code when I was 7 and professionally since 17. I studied computer science at the University of British Columbia in Vancouver, Canada. Worked at a number of local companies writing code throughout my studies. And towards the end of my last semester, I actually started my first company. So I dropped out and worked on that company for about 10 years, which was focused on massive scale web data extraction. Uh, and then eventually I started working on Puter in 2021, first as a side hobby project, and then I turned it into a company, and here we are right now. Uh, my passion revolves mostly around the web and distributed systems. For the past, I would say 15 years, this has been my focus. I've done a number of other projects along the way. Well, I'm an open source maximalist. So I have a lot of open source projects, the most successful being Puter, but I've done a lot of other open source projects such as Puter.js. This probably doesn't count because it's the SDK for Puter, but it's a pretty popular project. And then I have KV.js, which is in-process caching module for Node.js. It's a mouthful for basically a simpler Redis clone for Node.js. I have Oops.js, which is undo redo module for JavaScript applications. PHP work, which is web archive handling in PHP, and a number of other projects. But in this talk, I'm focused on Puter. So what is Puter? In short, I would say Puter gives every user a computer on the internet. So if you go to puter.com, create an account, you will be given a small cloud computer connected to the desktop environment that is rendered in the browser. Basically, this cloud computer has limited storage, some database, some other types of resources like compute, and it is interfaced using this desktop environment, meaning that you can access your cloud computer from any device that has a browser with this super familiar Mac OS-like, Windows-like interface. All of this is rendered in the browser, which I'm going to get into later. What do they use it for? I mean, this is the most common question. Why would you even do this? And what is the purpose of this? Well, just like any other computer, if I dare say so, just like any other computer or operating system, it's very general purpose. So people use Puter for a variety of reasons. A lot of people use it to simply store files. I would say a better alternative, an alternative to Dropbox, Google Drive, and OneDrive. So you can put your files in there and you can access them from anywhere at any time. The good thing about it is that you don't really have to install any applications. You have a device that has a browser, you can log in, you can access your files. Basically, that means a lot of devices out there, whether it's your phone, your laptop, your desktop computer, your Tesla, your VR headset, anything that has a browser, Puter does a good job running on. We have a lot of apps and games. So not only can you put your files in that cloud operating system with the desktop environment experience, you can also open those files and you can modify them. A lot of productivity applications, word processor, spreadsheet, presentation, basically an entire Office suite. We have code editors, photo editors, video editors. You name it, we basically have it. We have a lot of games as well. Strategy games, puzzle games, action games. So a lot of people just show up to Puter to play games. Again, it's very general purpose. People use it for different reasons. Some people write code on it. Some people play games. Some people use the productivity applications or simply store files. But one thing about Puter that is very unique to it is because it's completely cloud native. This whole thing is running in the cloud. Only the interface is being rendered in the browser. Because of being cloud native, you can actually directly write code on it and publish websites and applications using it. So as you can see in this screenshot, I have this directory on my desktop it contains, for example, an HTML file. I can right-click on it, just publish it as a website, and boom, because it's a cloud file system, so it's connected directly to the user, and the website is just published there. You edit the file, it's automatically updated. As you will find out later on in the talk, this is actually a very, very important part of Puter and why the broader audience of developers use it. If you want to get started, here's my curl to bash. I didn't have this slide in actually when he was talking about curl to bash, I put it in. So you can use the curl to bash, and we have the hosted version on Puter.com. Pretty easy to install. You can get started. We use a really cool thing about Puter was that you could go to Puter.com, it would just provision the desktop for you, but we put a sign-up wall in front of it just because of the sheer amount of abuse we were getting. So you can self-host it easily, or you can just go to Puter.com and use it. Now, in terms of what I'm going to talk about, a few things about Puter. This is mostly a technical talk, but first of all, Puter is open source under AGPL. I would say more than 90% of what you see on Puter.com is actually the open source project, plus a number of proprietary extensions. I'll get more into that soon. Puter is monolithic. One repository, pretty much everything that makes Puter work. It's all in there. The backend, the front end, the SDK, the documentation, all of it. We are a JavaScript shop. The vast majority of the code base is written in JavaScript for reasons that I'll get into soon. And then there are three major pieces to the project. One is the backend, obviously the what we call the distributed cloud operating system with servers all around the world, doing all the distributed stuff behind the scenes so that the user or the developer is not exposed to it. The front end, which is the desktop environment, and Puter.js, which is our SDK that allows the desktop environment to use the backend and allows applications to interact with the desktop environment. It's also isomorphic, and you can use it on in any other environment, basically, that supports JavaScript. Puter being an open source project, for the first 3 years, it was actually not open source. I was working on it as a closed source project. I put it on Reddit, it blew up, and they convinced me to open source it, amongst other things. There were a couple other people that really pushed me to open source it. We open sourced about 2 years ago, and so far we've amassed 41,000 stars, vanity metric if you care about it. 400,000 downloads and 373 contributors, which I think is the most important part of it. We also have a couple thousand forks under our belt. It's been forked. Puter has been forked by a lot of other projects. It's pretty popular in crypto. People, if you know Web3 and the idea of a computer in the browser is something that the crypto community really takes a liking to. And it's being used by other projects as well. I know of one company in China that's trying to fit Puter into cars. Hopefully they're successful. That would be good for us. So it's all over the place. It's very interesting to see how people fork and try to adapt Puter for different environments and use cases. Moving on to the monolithic architecture of Puter. Again, Puter is a monolithic repository. Everything from the backend to the front end to the SDK to the documentation, all of it is in one repository. There are a couple of reasons for that. One, which is my favorite, is that the changes are pretty much atomic across projects. So you can do a full stack change when you need to ship a feature or fix a bug. Everything happens within that project. So one build process, one installation process, and one runtime. So that's really my favorite. And I think this whole thing started as my preference of building applications, which was mostly in monorepos. Again, easier full stack development and testing. You want to ship a feature for end user applications for the user space. You want to ship something for that particular part of the project. Typically with a project like ours, which is still young, you probably have to do something in the backend, change the SDK a little bit, write tests for the backend, for the SDK, for the front end. So it's happening all across the stack. And being a monorepo makes that much easier. And the third reason, which is not really technical, is that if something is within the monorepo or the main project, it just gets more developer mindshare. There's a network effect to having repositories that, again, vanity metric, but have a lot of stars or have a lot of contributors. People want to contribute more to those projects rather than smaller ones. So if we have a lot of repositories under our org, for example, if we break out documentations, which we did, into a separate repository, typically we don't get that much contributions. So we put them all into one repository so that people can claim that they contributed to this big project, which is true. Documentation is obviously a big and important part of any open source project. But we've come to learn that they want to contribute under the name of Puter, the main project that has a lot of views on it and gets more mindshare. So that's one non-technical reason for it. And recently, having a monorepo is actually super AI friendly. You can tell your agent, you can point your agent at the repository and you can ask it to ship a feature. It'll ship the feature, it'll ship the tests, it'll ship the documentation for it. If it's an API, it'll change the SDK as well. So all of it happens in one go, which I think is pretty amazing. Obviously, you can have sub-modules, and the sub-modules can be pulled into the repository, but having one agent's MD at the root of your repository just makes things so much easier. And generally, we lean on the community a lot. And that's why we want to have one central place to communicate with them when it comes to issues, projects, and things like that. Obviously, we have our Discord and other social spaces to interact with the community, but we like to have our projects managed on GitHub and Linear from one repository. Yeah, we're a JavaScript shop. We use Node.js in the backend, vanilla JavaScript in the front end. We've made some controversial choices when it comes to our stack, but there were some really practical reasons for picking JavaScript. One big reason is that we're sharing a lot of code between the backend and the front end. A simple example would be path resolution in the file system. Not a really big piece of code, but pretty intricate, and you want to get it right. So especially before AI, this was incredibly important. You want to save as much as you can when it comes to writing code. So the code that does path resolution in the backend is the same code that does path resolution in the front end. There's many instances of that in our code base where we're sharing backend and front end code. Obviously, that also when it comes to people working on the project, if you know JavaScript, you're likely to be able to contribute to the backend or the front end. So it also helps with that. One person can contribute to many parts of the project. For the backend, going with Node.js, once we decided we want to have isomorphic sort of a situation, we went with Node.js. But then again, even if I went to share the code between backend and the front end, I would have probably gone with Node.js for other reasons. But one big reason is the non-blocking I/O that Node.js offers. I mean, 2010, it was very important back then. But yeah, non-blocking I/O and Node.js is important when it comes to performance. But then again, you don't have many choices if you're going with JavaScript in the backend. So maybe this point is kind of moot in that sense. Also, one important reason with going with JavaScript is the great SDK ecosystem by vendors. So one choice I had for the backend, aside from Node.js, was Rust. But the problem was that, especially again before AI, Rust did not have good SDK support with cloud providers. So we couldn't really, I mean, writing an SDK for example, S3, that's very, very time consuming, especially without AI. And a lot of it, we use a huge number of vendors. We use a huge number of third-party APIs in our backend. So not having SDKs for those would be very time consuming. Again, even with AI, it's still, you don't want to write this stuff from scratch. you want to use the SDK provided by the vendor. Now AWS does actually have the Rust SDK, but some of the other vendors we use still don't. Another pretty good reason for using JavaScript, there's so many developers out there that know JavaScript. By some estimates, 28 million. Seems a little too high to me, but yeah, I would say there's probably millions and millions of JavaScript developers. And it's a very simple language. It's not difficult to understand. The abstractions are pretty shallow. You can get started with JavaScript very quickly. I think back in the day when boot camps were big, they would either teach Python or JavaScript, mostly JavaScript for people getting started. So there's a lot of JavaScript developers, and the pragmatic choice here when it comes to the knowledge around the language is that you want to go with something that is very popular and a lot of people know, just so that you can increase the pool of contributors and people who can connect with the code base. All that said, we do have other languages in our project right now. We do have Rust now for our networking layer. We have Python for some of the tooling. So it's actually expanded beyond JavaScript, but still the extreme majority of the backend is JavaScript, the front end as well. We have some WASM and things like that in the front end too. Now the backend. So one of the reasons we call Puter an operating system, I would have called it in the beginning of the talk an operating system, but I think I'm in the wrong neighborhood. I shouldn't call it an operating system. So I call it computer when I'm a little scared. But one of the reasons we call it an operating system or a cloud operating system is because what it primarily does in the backend, and most of the magic, honestly, the desktop environment is nice and all, but most of the magic is actually happening in the backend. What the backend does is that it basically manages resources and provides consistent API to applications. That's what it does. I mean, at the end of the day, that is also a classic definition of what an operating system is, whereas the classic definition of operating system has to do with hardware. With Puter, we're talking about cloud services. So the cloud file system, the database, the networking layer, and a lot of other APIs that are integrated deeply into the backend and applications can use. So that's partly the reason we call it. The backend is responsible for that. It's written completely from scratch. For building Puter, we tried so many different approaches in the beginning. Well, I tried. It was only me in the beginning. I tried so many other approaches, streaming containers, VMs. If you remember a few years ago, the browser is the new OS was all the rage. So I tried forking Chromium and trying to do all that. None of it worked. At the end of the day, I realized if you're actually serious about this, having a cloud OS with a separate interface, you have to write the whole thing from scratch, the file system, the database, all of it. These days, our focus is mostly on simplicity, security, and stability. So we don't allow feature creep. We say no to a lot of features. I think we have all the features that backend needs for the most part in terms of really big APIs. We have the file system. We have, as you can see, the distributed file system, the database, the AI integration, AI gateway integration, authentication, everything that you need to basically ship or run applications, we have it. So we are mostly focused on the S3. We want to be simple, secure, and stable. In fact, we've recently done a major refactor of the backend, removing something like 100,000 lines of code. And improved our stability significantly, added a lot of test coverage. So when it comes to development of the backend, this is what we're mostly focused on. There are two really interesting parts to the backend. One is drivers, just like device drivers we were talking about. We do have the concept of drivers in Puter as well, which allows Puter to interact with outside services. And given the number of developers that are using Puter to build applications, I think that is more and more becoming something important for anyone who provides an API. I wouldn't say important, but it's very attractive to them to get integrated into our backend. And this driver system that we have actually allows for a standard way to build an integration with our backend. So a driver system completely inspired by how drivers are done in operating systems just adapted for our use cases. In fact, we very recently did a partnership with an AI inference provider. We went through the driver method. We shipped the driver. It was pretty easy. It's in the open source. So it was really well. The concept of drivers completely mapped to the cloud. And we have extensions. So extensions are a bit different. I did another talk that is going to be played soon after this one, in which I talk about the challenges of launching and scaling a large open source project. And I think one of the biggest mistakes we did in the beginning is that we didn't have an easy way for us to ship the open source project to the proprietary code base or deploy it to production. Any open source project, any commercial open source project typically has two parts. One is the open source project, and the other one is the proprietary version of that. Now, if you're not careful, you're going to end up building two products at the same time. Even though they look and behave the same, it's so difficult to get the tooling right that you end up having two separate code bases. One is the open source one, and the other one is the proprietary one. And you're managing basically two products. This thing, extensions, is basically an easy way that allows you to extend the functionality of your code base, of your open source project with proprietary code. I wish we had done this earlier when we launched the project, when we open sourced the project, but we didn't. And it took us a very, very long time, almost 2 years since we open sourced to get this right. But now we have an extension system that allows you to easily extend the open source project with your own code. For example, the payment infrastructure of Puter.com is actually an extension to the open source project. The way it works, I'm not going to go too deep into it, but the way it works is that you have hooks. I'm not sure if you're familiar with WordPress, probably are. There are hooks in the code base that send events out, and these extensions can pick up those events, do something to them, and then return it to the core. So you don't have to understand how those 300,000 lines of code in the backend work. And honestly, all you have to know is what those events are, how they look like, and you can just pass them around as extensions. So if you want to add payments to Puter, it would be a completely separate file. It just takes that event in, changes it, takes a look at it, says, oh, okay, this, for example, this payment went through or not, and sends it back to the backend. You never have to go in deep into the code to understand what's going on. This is one thing I recommend anyone who's doing something similar to Puter, where you have an open source project and a hosted proprietary version to look into. I think that's very important. The front end. The front end, being mostly the desktop environment, is fully rendered in the browser. Most of the time when somebody goes to Puter.com or when I'm showing them Puter, they think that we are streaming the desktop environment from a container or from a VM. That's not the case. The entire desktop environment experience is rendered in the browser. That thing is completely JavaScript, CSS, HTML. That's it. Nothing is being pixel streamed from the servers. The reason for that is, first, is the cost. I mean, if you're hosting on AWS, you have to pay 10 cents per gigabyte, and that's very significant if you have a lot of users. So first one is the cost. It just is very costly to stream pixels. The other one is performance. No matter what you do, unless you have a lot of edge servers, you are simply not going to get the type of performance that somebody expects from a desktop environment. You click on a folder, you just want it to open. You don't want there to be latency or lag. And if you're pixel streaming, you're out of luck. There's at the end of the day, you're going to hit the limits of physics. We decided to do the entire desktop environment in the browser. Obviously, it was incredibly difficult. It took a very, very long time to make it stable, to make it work right. But it is pretty stable now. It rarely ever crashes. It's a pretty good experience. I did some controversial, I made some controversial decisions when it comes to the architecture of the front end. I didn't use any frameworks. It's not based on React, Vue, Angular, or anything like that. And when I open sourced Puter and got a lot of attention, this was one of the points of flame wars on Reddit, Hacker News, and everything. And I mostly stayed out of it, but it was fun to watch people getting so religious about this. So I didn't go with frameworks for two reasons at the time. Well, I would say three reasons. One is the performance. With desktop environment, we're dealing with a completely different league of performance issues than a regular, for example, SaaS application dashboard. There's a lot of rendering happening. There's a lot of DOM manipulation that frameworks are just not good at, and they're not designed for that kind of interaction. So that was one reason. That would be a major reason. The other one is that pretty much every single really, really performance intensive web application that you see, OnlyOffice, Photopea, I think even Google Docs, none of them use frameworks for the manipulation of the DOM in the browser. And they're all using either their own way of doing things or Visual Studio Code. That's a really big example. They're not using frameworks for pretty much the same reasons as the ones for Puter. Performance, and the third one would be you just want to be in control of your destiny. If any of these frameworks, and I'm old enough to see frameworks really peak and then disappeared into nothing. So if a framework is abandoned, again, now you have to maintain a framework on top of what you're doing. So I rather just use the base technology, the base open technology, which is the web APIs provided by the browser. I decided, since it wasn't enough flame war when it comes to frameworks, I decided to use jQuery of all things. If you're familiar with web applications, jQuery is this pretty old, I would like to call it pretty mature, but people call it pretty old, library from 2008. It was designed for a time where there was so many issues with moving one piece of code from one browser to another. jQuery's whole value proposition was that, hey, we're going to make this easy. You use our API, and then your code is going to run everywhere. And it did. It's very. I think it's still being used by millions and millions of websites. Um, I decided to go with jQuery for another reason. I think the API is incredible, even though a lot of it has been absorbed into the standard JavaScript provided by the browser, but there are still some APIs that make it really the the DevX is really, really good. So those APIs help you write code faster, and the code is pretty defensive. You're not going to run into issues because you got a loop running around elements in HTML and things like that. To be honest, I think I keep bringing AI up, but I think because of AI, this stuff is not that big of an issue anymore. I don't think AI makes mistakes when looping over elements. So you don't even need jQuery for that. Uh, but when I was working on the desktop environment, there was no AI, so I had to hand roll everything, and this stuff really mattered. Um, Now, the app runtime on Puter, if you go to puter.com and you open applications, you see the windows just like a regular desktop environment. You see these applications that run in the desktop environment. Those are iframes. So the runtime for applications on Puter are iframes. Those are web pages being loaded in iframes, and that iframe communicates with the desktop environment and the backend using the SDK. So the runtimes of our desktop environment are iframes, which also gives us some really incredible powers. The most important one being sandboxing. I mean, iframe sandboxing, browser sandboxing is just incredible. The entire IT industry depends on it. You log into a bank, your online shopping, whatever you're doing, you depend on the sandboxing powers of the browser. So it's very robust. And we're taking advantage of that for our app runtime, which gives us incredible security. There are IPC issues and we've caused many of them, that kind of messes up with the sandbox promises of the iframe, but that's another discussion. The front end also has the same extension system. Once we realize how badly we messed up with having only open source and no extension system, we implemented it in the backend and immediately implemented it in the front end as well. So the same extension system we have in the backend, we also have it in the front end. You drop a file in there with your proprietary code, and it's just going to work. And last but not least, that desktop environment is largely artisanal. I hand-rolled everything. Well, after we open source, we got a lot of contributions, but there wasn't much AI used for the front end. And still, because it's been stable for a long time and we don't touch it a lot. It's still the same handwritten code from all these years that we didn't use agents on it. So the majority of it is actually, as they call it, artisanal. This is the before and after of the desktop environment. The first version, the very, very first version, the first day I was working on Puter, I took a screenshot of it. And this is how it looked. And this is from, I think, a month ago. So it was only a modal with the terminal. You double click on it, it would show this thing. I don't even remember if there was a terminal in it. But yeah, we've come a very long way. The SDK, Puter.js. So the entire desktop environment and applications inside of it are actually powered by the SDK. So not only do the applications use the SDK, but also the desktop environment is dogfooding it as well. We call it Puter.js, and this is the project I brought up in the beginning. It's part of Puter, but I'm really proud of it, so sometimes I introduce it as a separate project. It's isomorphic, first and foremost. It runs in pretty much any environment that supports JavaScript. Obviously, the browser, that's its home. Node.js and workers. Am I missing something else? I think these three are the main ones. So isomorphic library that can run anywhere that you have JavaScript. It gives the developer a true serverless experience. So all these applications that you load on Puter, they are fully connected to the backend, and there's no server in between. And this is the real power of Puter that is lost in all the desktop environment and all the craziness that's happening around that. But what it gives developers is a true serverless experience. If you build an application, whether it's on Puter or not, because again, Puter.js is isomorphic, your application is going to have cloud storage, database, networking, AI, compute, I mean, whatever you can think of, and it's completely serverless. You don't have to set up a proxy. You don't have to work with containers. You don't even have an API key. In fact, you don't even need an account to use Puter.js because all of that is handled by the way Puter provisions the scoping around authentication, which is, I mean, we don't have to get into that, but that really, the end result of it is the real magic of Puter. It's a user pays model just because, you know, when you give every user a computer on the internet and they can take it to different applications or open different applications in it, that means those applications are running in the user's account rather than any other traditional way of building applications where the developer is provisioning infrastructure and is basically renting it out to different users. In this case, just like the good old days where you would buy software, you put it on your laptop and you're paying for the infrastructure, same thing happening here. So we've gone full circle. What's happening is that the application is running within the user's account, meaning it's consuming the user's resources, just like a laptop, or you think of it just like the user bringing their own wallet to your application. What that means is that what we call it the user pays model or bring your own backend. That in practice means that whatever application you build on top of Puter is actually going to be completely free in terms of infrastructure for you. So even if you build a Dropbox on top of Puter with 1 million users, one user to 1 million or to a billion, it's going to be free for you. You're never going to pay $1 in infrastructure to us. Every user covers their own usage. As far as I know, we're the only people who've ever done this. I haven't seen anything like it. I think Anthropic is doing something similar when it comes to AI somewhere in their projects. I saw something, but we are pretty much the only people who've done this. The SDK is available on NPM and CDN. Interestingly enough, most people and AI prefer CDN, it seems like, which is surprising because I would have thought NPM would be more popular. And all the stuff I talked about, being isomorphic, really, really serverless, like in the truest sense, purest sense of the word, meaning you don't have to create an account, you don't need an API key, you don't need any of that. That actually accidentally made Puter very popular with AI agents. And it's sort of becoming the backend for AI coded apps. I would have never imagined this would be the use case, but especially since AI agents took off, I would say within the past 1 year, we're seeing more and more apps just defaulting to Puter.js, which is a very, very interesting development right now. But this makes AI apps secure and scalable by design. The problem with vibe coding or AI coding applications right now is that, for example, you go to your AI agent, you tell it to build me a to-do list, and it starts building the to-do list. It does a front end, and it looks nice, but all of a sudden it'll tell you, okay, go create an account on this cloud provider, get me the APIs if you want to actually deploy it. Give me the API keys, put them in the backend. Now you have to put the backend somewhere. And then all of a sudden you have the code, but good luck running it, especially if you're non-technical. And then you have to scale it and all of that. But with Puter, you take that SDK, the AI actually knows how to use it already. They take the SDK, they drop it in the HTML file, and it just works. They don't have to ask you for API keys, for an account, nothing. So that's why it's become a hit with AI. If you want to give it a try, it's no curl to bash. You don't need it for the Puter.js test. You can just go to your Codex or Cloud Code or any other AI coding assistant and just tell it build and run a to-do app using Puter.js. Now, as far as I know, they all know how to use it. So they're just going to churn out the code, they're going to run the server, and they're going to show it, and it's going to be fully cloud native right off the bat. You will see how it works. Now, just going back a little, I forgot to tell you about this. Now, the way it works, when you use Puter.js in your application, the way it works is that it's automatically going to ask the user to log into the application using their Puter account. Basically, it's asking them to bring their wallets with them or allow the application to tap into that cloud wallet. So this is the permission prompt that I forgot to talk about. It's basically asking the user to log in or create a user, and then everything just works. If you ask AI to build an application, it'll pretty much look the same. The application will show up, and at some point, it's going to ask the user to either create an account or log into their Puter account to make it work. These are some of the applications that are built using Puter. There's games, there's Polotno, the photo editor, music player, Judge Zero, which is a code execution IDE plus IDE in the browser. This is a browser that uses our a networking stack. We have pretty much everything you could imagine when it comes to it, but it's really fun to see how this is getting into the long tail of applications developed by AI. You can go to developer.puter.com/showcase if you want to see some of these applications. As we add them, we just shipped it a couple of days ago. So if you want to see how popular, this is why I'm so proud of it, how popular Puter.js has become. I think I honestly don't remember exactly when we shipped the isomorphic Puter.js. It was sometime in mid 2024. So by March 2025, we had 1,400. This is wrong. This was December 2024. Sorry about that. So in December 2024, we had 500 new apps added, 500 new apps powered by Puter.js in 1 month. So something around like 15, 16 apps a day. And by March 2025, that number grew to 1,400. So this is the graph from December to March. And the end of that graph is March 2025. And then, so this kept happening, and as AI took off, this started accelerating. And now, if you put that into perspective, we went in January again, we had 1,400 total apps, and then that grew. This is the total number of apps, and we're projecting 94,000 total apps in May 2026. So it accelerated incredibly dramatically. Part of it is, well, we got lucky, because Puter.js is just a good match for AI. And I think just the fact that AI took off the way it did within the past 1 year, that everybody's shipping applications helped a lot. And also AI already knows how to use Puter.js. That's why when you prompt it to use Puter.js, it just knows how to do it. I've noticed that recently it does go to the documentation if it needs it, but even before that, it already knew how to use it. I think all the code on GitHub and all the documentation that we published even before these tools were so popular just made it into the training. So yeah, it's been growing very dramatically. It's caused a lot of issues. Obviously, we never expected it to grow like this. We had many outages, but we're super stable now. For I would say maybe something 8 to 9 months, we had constant outages. It was hell. But after re-architecting a lot of stuff, the refactor of the backend, making a lot of changes, moving to containers in the backend, um, we have it under control. We have pretty good. I think we're at almost 4 nines. Yeah, I don't want to I don't want to get that wrong. So I think it's 3 nines, something like that. And when it comes into availability, which is pretty good for something like this. So the question is, what is Pewter? I think increasingly it's becoming the infrastructure for AI apps. This is the highest growth area I'm seeing in Pewter, even though the desktop environment is being used a lot. Especially before people were using AI agents to code, our code editor was incredibly popular. We had something like 10,000 daily users for the code editor alone in the desktop environment. But I don't see many people writing code by hand anymore. So that part is not as popular. But what really blew up is definitely the infrastructure and the SDK. So again, increasingly, I think the best definition for Pewter would be the infrastructure for running AI coded applications. That's about it. Thank you.